Our next session is titled Data Scientists in Retail, Essential Lessons for Growing a Successful Data Science Team. It will be led by Joe Barry. He's worked for Edited for 4 years as a senior data scientist, solving complex challenges within the retail industry. It includes image-based machine learning, NLP, and statistical modeling. He has a master's in Advanced Computational Aeronautics from Imperial College London and a master's in physics from the University of Nottingham, where he specialized in computational modeling. Please join me in welcoming Joe Barry to the stage.
Thanks. Thank you. Good afternoon, everybody. Just to repeat, my name's Joe Barry, and I'm a senior data scientist at Edited. And welcome to my talk on data scientists in retail, essential lessons for growing out a successful data science team. Before I get into the good stuff, I just wanted to give a bit of context as to what Edited is, who I am, and why I wanted to give this talk today. So Edited is a platform for retail analytics. It's powered by big data and data science. Simply put, we help people make data-driven decisions in retail. We help retailers understand things like competitor pricing analysis, discounting, assortment, visual merchandising, trend analysis, etc., etc. And we allow them to make powerful use of our data to try and stay ahead of the market. Our marketing tagline is right product, right price, right time. I like numbers, and here are some numbers that I think sum up Edited pretty well. We were established in 2009. We have 3 offices in London, New York, and San Francisco, and we have over 120 employees today. We have over 500 million products in our database, spanning back all the way to when we started, till 2009, so we have a lot of data. And this is equal to about 1.5 billion SKUs. We also have almost 1 million types of newsletter, promotion, homepage that we track as part of our visual merchandising offering. So data and our ability to manipulate it is our main commodity. So it makes sense that data science is the core of our business. And our data science team works on a range of problems, but I broadly summarize them here. We have classification of products, both based on text and image, trend analysis, insights, crawling ingestion, data QA. And we've been on quite a journey as a data science team. I was the second data scientist to join 4 years ago, and we've roughly doubled in size each year. It's not exactly stellar growth compared to some other companies, but I'm going to explain a bit later why a slower growth model has actually worked really well for us. So as we've grown, we've had to make many decisions about how we work, our team structure, and how we maintain a positive work environment. We've gone from 1 or 2 data scientists working very independently to a fully integrated team that work across multiple disciplines. This is purely a representative graph, but I just wanted to give an example of some of the difficult decisions that we've had to make as we've grown over time. Things like who's going to work on what, how are we going to approach mentorship, management, project ownership, R&D, career growth, KPIs, and reporting. On our journey, we thought that actually it might be quite nice to document what we've learned. We've made a lot of good decisions over time, and we've made just as many bad decisions. And we've also taken a lot from existing approaches. Over the last year, I'm sure most of you know that data science has exploded in popularity, and this has been good because we're now seeing a lot of content out there that's focused on how to build out your data science team, how to integrate it into your business. You've got everything from blog posts, white papers and articles, all the way up to consultancies like Accenture, bringing out full-on guides on how to integrate data science in your business. But there's a lot out there. So we kind of took all of this information and we wanted to distill it into some of the important lessons that we've actually learned on our journey that we feel has led to building out a successful data science team. These lessons we feel could be useful to others looking up to scale out a data science team, and we think that they provide a strong foundation on which you can build a team that works efficiently within business, but also has a positive working environment. So let's get on to the lessons. I've picked out 5 of the more important lessons that we would have liked to known when we started out, and we definitely didn't. So I hope this is of some use to you guys. So, lesson 1, as you might expect, is probably our most important lesson. It was recently summed up in a brilliant blog post in Harvard Business Review, and I've got the link at the end of my presentation if anyone's interested. And this lesson is that data scientists work best as generalists. And when I say generalists, what do I mean? Well, I like to think of generalists summed up by the phrase, jack of all trades, master of none. I don't know if that's just an English saying, but basically what it means is that a generalist is good at many things, but not necessarily an expert in one particular field. The opposite of a generalist is a specialist, and that is someone who specializes in a certain field. And it's actually specialists who are more desirable in business generally. They've long been associated with increased productivity. Historians, philosophers have often attributed the division of labor to economic growth and the rise of nations. But why are specialists more desirable in business than generalists? Well, I've made an example to try and demonstrate this, and this example I've made with my limited knowledge of fashion, and I've based it on the idea of we have a designer who designed a really cool dress. They want to make as many copies of this dress as possible so that they can make lots of money and sell it to people. They've got enough money to hire 5 employees who know nothing about dressmaking, but these employees are obviously willing to work for money. So let's say this designer employed a generalist approach to the dressmaking. Each employee would be responsible for making each dress. So the dresses would be being made in parallel, but each employee is responsible for every step of the dressmaking process, from fabrics, trims, sewing, cutting, selling. I know there's a lot more, but I've tried to just simplify it down here. So what happens is that actually these employees know nothing about making dresses. So the quality of dresses will start off really badly. They will get better over time as these employees learn these skills, but these employees have to learn all of these skills all at once. So the rate of increase in quality is quite low. And I think you can see where I'm going with this, because if we actually approach this in a specialist way, the workflow would look more like this. We're now making only one dress at a time. But the difference here is that each employee is only responsible for a single step or a single skill in the dressmaking process. So again, the quality would start off low because they don't know anything about making dresses. But because we're allowing our employees to narrow down their focus to a single skill, actually what happens is that the quality of dresses will increase much quicker than if we were to stick with a generalist approach. And also the speed of working would go up much faster because these employees would become experts much quicker. And so this is why, generally speaking, specialists are favored in business. All business has some degree of specialism: marketing, sales, engineering. Data science itself is a specialism. And then you can have specialisms within that. So this is what we did when we were tasked with scaling up our data science team. We split data science up into specialisms, and we looked to hire specialists in data science. Different people on the team are responsible for different areas. But we quickly hit a few problems. One of the main problems was hiring. So it's always going to be a bit harder to hire if you're looking for a very defined specialism. But not only that, but we didn't actually really know what we were looking for because we weren't specialists in text classification, say. So we didn't really know what an expert in text classification might look like. Also, the siloing of specialisms in our team led to some sort of unfavorable occurrences. So we might have 2 projects focused on one specialism. So 2 projects ready to go around text classification, but only one text classification specialist. So we would have delayed projects. But if someone was available to work on that project, the handover cost or the coordination cost to get that person up to speed in an area of text classification or even in an area of just within our business was high. Our employees didn't have good context about what the whole team was doing or about other areas that we were working in. Probably most importantly, it really led to a lack of job satisfaction. By siloing our employees, we found that actually they were getting quite frustrated having to kind of work on the same problem when they know, and they weren't stupid, that there's a huge area or variety of things you can work on in data science. So we had a real lack of job satisfaction. And this also led to a lack of creativity because we had the same minds working on the same problems. So the quality of our work as a team, we actually felt went down. And this made us come back and think, where have we gone wrong? So we kind of realized that actually specialists are really good in a team when you know exactly what you're outputting. So if your team is focused on execution, specialism is great. We've already designed our dress. We just want to produce as many of them as possible. But data science isn't a production line. Data science is less focused on execution and more focused on research and development to enable big step change developments in business capabilities and technological areas. There's no blueprints for a lot of what data scientists develop. It must be learned and not just implemented. In data science, you learn as you go through research, trial and error, and iteration. And it's a very creative, exploratory process. After we realized this, we kind of stopped trying to hire specialists in data science, and we kind of moved more towards this our idea of generalism. So we started to hire competent data scientists, but they didn't necessarily need to be experts in a particular field. We took faith in our team to work in a wide range of capabilities, and actually found it a lot easier to hire and find really, really strong candidates for our team. We don't have any restriction on what people can work on now, as long as they show an interest. And obviously, this does come with a cost of learning on the job. Our employees are now more likely to be exposed to new concepts and new ideas, but we feel that this is actually somewhat offset by the freedom of resource. We now have multiple people who can work in multiple areas within our team, and there's actually a reduced handover cost because our entire team has a much better understanding of what's going on in the various areas within our team. Importantly, there's a massive increase in job satisfaction. Our employees have reported that now they feel like they're really learning on the job, they're much more engaged with what they're doing. And also, we feel like the quality of our work's gone up. We now have multiple viewpoints coming at similar problems, so we're getting much more creative in the kind of solutions that we're coming up with. So just to summarize lesson 1, which is my longest lesson, don't worry, it's much quicker from here. We really think that you need to allow for generalization if you want to maximize the potential of data science in your business. Right, moving on to lesson 2. That is ensure data scientists take ownership. This goes hand in hand with lesson 1. Through generalization, we're able to promote the idea of data scientists not just doing some research and exploration at the beginning of a project, but actually taking it all the way from conception until that product, feature, whatever, is released and live in our software. So at Edited, most of our engineering projects start with data science because it powers the majority of tools and features that we use. A very simplified workflow might look like this. You've got your data scientist doing some work in research, model testing, model development, data collection. They've done their work, great, and now it's time to get other disciplines involved. Your back-end devs, your front-end devs, marketing, etc. Normally, the data scientists we'd meet up, have a handover, and they would go on their way and start the next data science project. But at Edited, we actually prefer our data scientists to stay with the project all the way through to completion. We want our data scientists to work closely with these teams to make sure that this project is done as efficiently as possible. You could argue that that's less efficient. The technical work in data science has been done, so why are we stopping our data scientists from going on to the next project and using their time in a more efficient manner? But actually, this goes against the idea of generalization. And we actually think that the trade-off is worth it because ownership is really, really important to us. We found that by making sure our data scientists are responsible for a project all the way through until it's live, even if their actual technical work is finished, we find that it leads to faster moving projects. By keeping the person involved from the beginning, there's less knowledge leak and there's less handover costs. Projects get done. There's a data science champion pushing this project all the way through. It's more in line with the idea of generalists and learning on the job, and it really promotes a sense of accountability for our team members, which is really, really important. And finally, it's really good for building relationships between disciplines. We've got data scientists pairing with developers, working with marketing, working with our UI guys to see how best to implement this feature. And in the long run, that really leads to an increase in productivity for the entire business. Sorry. Okay, moving on to lesson 3, and that is recognize data science-specific technical debt. Now, I'm sure some of you or most of you might know what technical debt is, but just to recap, technical debt reflects the implied cost of additional rework caused by design decisions as you build out your product or service. So if I've got feature B, if we can take a shortcut to get feature B live now, but that shortcut is going to require us to go back in the future and fix something in feature A that's already in the app, then that's us deciding to take on technical debt. And technical debt is a really well-defined concept in software engineering, and there's lots of things out there on how to manage it and how to account for it. But maybe a little less known is that actually technical debt also exists in data science, and it must be accounted for. I'm just going to go through 2 examples of the main types of data science-specific technical debt that we encounter at Edited, but there are many more. So the first kind of debt I wanted to talk about is training data debt. So training data is the labeled data that we use to build our machine learning models. So say we have a database of 10 million products. Ideally, we would manually label every product, and then we wouldn't need a model to classify what type of product it is. But obviously, we don't want to do that, so we take a representative subset of this database, say 100,000 products, and we do manually label these. But then this allows us to train a machine learning model on the training data that can go back and classify everything in our database. As long as the training data is representative of our domain, that is similar, it captures all the types of variance in our database, then it's going to be performant. But what about 6 months down the line, our database grows, or we decide to crawl a new market? Say we start to crawl India and we start to see saris that we didn't have in our database before. Suddenly, our training data is no longer representative of our database, but our machine learning model is still classifying everything in the database. So what you get is an impact to accuracy and performance of your machine learning model. And this is quite intuitive, and it's quite easy to manage when you just have a couple of models. But it can be a huge barrier to scaling, both in terms of the number of models that you're running in your production and also how big your database is. So it's really important that we recognize training data debt and prepare for it. At Edited, we definitely didn't. I remember when we released a new feature that had almost 100 models powering it. This was classifying kind of both product category, subcategory, and style level. And we had these performant models that were doing well. And then suddenly we did go and crawl a new region, and every one of these models dropped off. And we had to go back, triage, and fix this quickly because it was impacting our customers. What we really should have done is seen that this was coming. We knew it existed, but we didn't prepare for it. So it's really important that this is recognized. The other type of data science-specific technical debt I wanted to talk about is model framework debt. So a model framework is the software that we use to build our models. So for example, I've got this model here, and I want to build it in Caffe, which is a real framework. That's fine, but then I need to make sure that my infrastructure, my tech stack, can handle Caffe. But it can, so that's all good. But then 6 months down the line, I want to build another model. But then a new framework's come out called TensorFlow, which has some cool features, and I decide, actually, I want to build my second model in TensorFlow. Still, that's fine, but now I need to make sure that my infrastructure can handle both Caffe and TensorFlow. And with the rate that frameworks come out, this can happen, and this can happen really easily, that you've suddenly got multiple frameworks in your infrastructure. And it's so tricky because too many frameworks can lead to a bloated infrastructure that requires a lot of upkeep from DevOps and the data scientists. But if you just limit yourselves to the older frameworks, you could be limiting your model capabilities and performance. So again, it's just about knowing that this type of debt exists, and it's about asking yourself the questions when you're going to develop a new model. Is it worth trying this new cool framework out, or is it worth sticking with an older framework that still will work well? So we make sure that we're aware of this, and we also run bespoke projects to make sure that we'll sometimes migrate some of our older models to newer frameworks just to reduce that infrastructure overhead. Like I said, there's many more types of data science technical debt, but these are the 2 main ones that we encounter and we think are really important to be aware of. Right, 2 lessons left. So lesson 4 is a very obvious one. It's not a new lesson, but it is important, so I wanted to include it, and that is make time for learning. Why? Well, aside from the obvious benefit of upskilling your employees, making an environment where your team feel like they can learn fosters creativity, and creativity is the heart of data science. If we want to make large step change developments in business and in technology, you have to allow your team to grow through learning. Learning on the job leads to massive increase in job satisfaction and personal development, and it also goes hand in hand with the idea of promoting generalism. If you want to ask your team to be generalists, you need to give them time to learn. But how can you ensure that your team's learning while still being productive for your business? Well, this is a vastly covered area, and I'm not going to go into any examples, but you've got things like Google's 20% side projects things like that. But I'll tell you sort of the main way we do it. So we really try to create a team environment where learning on the job is not only accounted for, but it's promoted and expected. And we feel that lessons 1 and 2 go a long way to helping us do that. So by promoting generalism and a sense of ownership, you really foster an environment where employees know that learning on the job is okay. We also ensure that learning on the job is accounted for when scoping out projects in terms of time and resource. And we run things like mandatory 2-hour theory sessions every week, run by different data scientists, and they can cover a wide range of topics from statistics, mathematics, software engineering, et cetera, et cetera. So on to the last lesson, which might be slightly controversial, but this lesson is stay streamlined, which basically means don't grow your team needlessly. If you say this to investors, they're going to start groaning. It's the age-old investor paradigm of investment equals hiring, equals growth, equals success. And I'm not arguing with this. This is a tried and tested approach, and it's definitely true. The more people that you hire, the more you can do. The more you can do, the more business you can generate. And this is what we did at Edited. We came under huge pressure after we got some investment to scale up our data science team. But it didn't quite result in success. So what happened is we had all these new data scientists, and we had loads of projects and ideas that we wanted to get started on. So that's no problem. But what happened to our workflow is that there was a tight bottleneck. So the data scientist team were producing some really good projects that should feed into engineering products for our designers and our engineers, but they didn't have the capacity to pick up the rate of work that the data scientists started producing once we scaled up. But why, though? Because we were actually quite confused, because we had, that's an obvious thing. So we had tried to scale up at the same rate as other engineering disciplines, so we couldn't figure out why this happened. But after taking a look, we kind of came to these conclusions that data science projects are very easy to start. They're often the first step in engineering projects, and they're all focused on research and discovery. Data scientists are very inquisitive, so it's very easy for them to go explore an idea. What if I try this? What happens if this happens? So they're very easy just to get going. And if you combine this with the idea that I've mentioned a couple of times, is that data science projects can often lead to huge step change developments in your business, then they can open the door to multiple engineering projects at once. For example, if you've got one data scientist researching ways of trend forecasting and they make a discovery, that could suddenly open the door to actually 10 engineering projects for your team. So these projects aren't small bite-sized projects, they're large scale that require multiple disciplines. So what happens when you can't do all of the projects you want to do? Well, you have to move some out of the workflow and move them into probably quite a badly named Project Purgatory. So Project Purgatory is really not good, because once we stop projects and move them in here, there's a lower chance they're ever going to get started again. Some of them will never see the light of day. If they do get started down the line, then the cost of context switching in data science is very high. So if you go back to a project in a year, the cost to get it off the ground again is going to be very, very high. And this is another form of data science technical debt. But all in all, this leads to very unsatisfied team members. I'm sure you all know, but if you work on something and you don't get to see the benefits of it, you don't get to see the fruits of your labors, then your team satisfaction or happiness is going to go down. And this is what happened to us. So we scaled up rapidly, and we were producing a lot of good work. But our Project Purgatory grew massively, and this wasn't good. And this combined with another factor that's not related, but is equally as important, we also had a lack of team processes around onboarding, management, and development. We were like 1 or 2 data scientists, and we didn't really realize how much process overhead comes with scaling up. So these two combined to make us lose our loss of our first team members, which made us very sad. So we had to go back and figure out what happened, and that's why we came to this conclusion. So now, we realize that kind of data science does need to scale. Scaling is good, growing your team is good, but it needs to scale at a slightly different rate to the rest of your engineering teams. So we now ask ourselves the question, if we want to hire in a linear fashion in data science, can our design teams, can our dev teams hire can they take a non-linear increase in the amount of work that they're going to take on? And we obviously also spent a lot of time making sure that our team processes were more robust around management, personal development, and onboarding. So yeah, those were kind of the 5 lessons that I wanted to talk about today. Just to summarize, the first one was data scientists work best as generalists. Ensure data scientists have ownership. Plan for data science-specific technical debt. Make time for learning. And stay streamlined. We learned many more lessons, but these were the 5 that we really feel were the most important that we'd have liked to known at the beginning. And we feel that they've really led us to creating a team that is both productive within our business, but also has a really good, positive working environment. And I'm not saying that these can just be picked up and dropped into any business, any team. Every business is different, every team is different, but we do think they form a really good foundation for discussion and consideration if you're thinking about growing out data science capabilities in your business. Thank you very much.
Thank you. We actually have a few minutes for questions.
Sure. If anyone has any questions, feel free to ask now, or you can come find me after.
Okay.
So I was wondering a question about what you said with the result of bottlenecking when you hire in the data science team and you're not really assessing if the other teams can achieve that nonlinear growth. Do you have any way of assessing, like, if you had scaled up your data science team and all of these projects ended up in Project Purgatory, how many of them really would have gone nowhere? Like, how many of them did you not need to pursue and develop to begin with?
Yeah, it's a good question. So you mean how many of these projects in Project Purgatory were just more kind of exploratory? They might not have actually resulted in any engineering benefit. Yeah, so we do a lot of exploratory work, but it's really important in data science to make sure that any area you're exploring could potentially lead to value for your business or deliverable on KPIs. So another really important concept of data science isn't just letting your data scientists go roam completely free. You need to allow them to roam free and be creative, but within the confines of something that would deliver business value, because otherwise there's no point. So we always start data science projects with that in mind, with the potential of where could this go. And some projects do completely just, actually, we can't do that. But then they wouldn't even make it into Project Purgatory.
So quick question. So how do you establish the processes for the data scientists so they always deliver consistent, repeatable results? I mean, let's say one person quits one day and you want to fill that role. And you mentioned processes for hiring, onboarding, and then so how do you replicate that via a process? How do you establish that process?
For hiring and onboarding?
Yeah, and just getting results from the data scientist. If it's a generalist, not a specialist, how do you always get consistent results? Where, let's say, it's like a symmetry. You can just swap out a data scientist with a new one, and they follow a process, an established process, and they get consistent, repeatable results, like as a previous one, let's say. Do you have a process? Is that what you mean by processes?
Well, process is more, we actually, data science come from a vast range of backgrounds, and they work differently, and they have different interests. So actually, we don't try and sort of mold our data scientists into like carbon copies, drop and replace. People work differently. When I mean processes, especially around things like onboarding, it's giving them all of the tools and information they need to be open to how can they apply data science in retail. So some of them have never worked in retail. So we want an onboarding process that educates them about problems in retail. We also want an onboarding process that educates them about all the types of data that we have access to. And we want a process where we allow them to know how the app works and how developers work. But we don't necessarily have a strict process being like, you need to have achieved this by 4 months down the line. Because data science work quite differently, I think.
When you made the switch from going after specialists to generalists, how did you adjust the way you were hiring to target people who work better as generalists versus specialists?
That's a good question. Yeah, because hiring was the first sort of sign that we realized maybe we're approaching this wrong, because we initially put out ads for people who, experts in NLP, and the hit rate was low. We weren't seeing good candidates. And it was literally a case of changing what we were looking for. So instead of saying you need 4 years of NLP experience, we had basic requirements for data scientists, but we removed the idea of although I am a senior data scientist, we remove that idea of seniority in data science. So in our ads, we don't necessarily say we're looking for a data scientist with X years of experience. We have a requirement, and then we'll get junior and senior applications all from the same ad. So we try to keep them general. We do have like a list of basic skills that we need within data science, but it was really changing the wording of what we were looking for in our job ads.
Data science is a very forward-looking discipline. Can you talk about the predictive nature of your solution, like some of the specific things that you do to predict?
Yeah, sure. You mean more like in technical work of like what we're exploring and trend?
Maybe more for your clients. Like, do you have some predictive solutions for your clients that you apply data science?
Yeah. So if I go back, I can give you just some. Oh, this might be long, but. I'm just going to show you this slide of what we work on just to give like. So when we first started, our whole goal was about classification because we ingest a huge amount of data from multiple retailers from multiple markets. So we are ingesting hundreds of millions of products now. And the first task for our data science team was standardization because people call different products, different things, and we wanted people to be able to search for camouflage shorts no matter what it was called, what it looked like. So that was the main goal, and that was about at least the first 3 years of our business was all about can we produce accurate machine learning classification models. But now, as we've scaled, and that's been great, is that now we're getting more into this idea of forecasting, trend analysis, and insight generations for our customers. Because our platform is sort of an analytics platform, it's kind of evolved. It's been, at first, just an access to the data, and you kind of draw your own insights. So if you're interested in a certain market or a certain retailer, but now we're getting to the point where we can add value on top of that by actually providing insight models to tell you when your competitor might have adjusted their price or when might be good to adjust a price point for your product. But that's only been possible now that we scaled up a lot more because that wasn't our first focus.
All right. Well, thank you so much.
Thank you very much.